Okay, today we will be learning about transistor sizing. Now, what is transistor sizing? That is the W and L, the calculation of W and L that we have already seen, but we didn't understand that time. And today I'm going to make you understand. So what to do? At first, let's draw a circuit, then see the sizing. Okay. Now, when it is a NOT gate like this, like the lab 1, the sizing was W is equal to 12 in your lab, right? And L is equal to 4, no, not 4, 3 micrometer. For NMOS, the W was 4 micrometer, L was 3, right? Now, what is the, what should I say? What is the benefit or importance of these two statements, W and L? What do I mean by this? Okay, what do I mean by this? Now, here, as an output, we have seen our graphs. This is 2.5. This is 2.5. This is 5. So our graph actually goes through the middle, right? As an output, since we have changed all of those. Can you hear me?
Yes, sir.
Okay. Since we have calculated the W and L and we have adjusted those, that's why our graph goes exactly through the middle point. That means 2.5, right? That was what we wanted. That's what we wanted. Why we wanted that? Because that maximizes the noise margin. Here, the noise margin is 2.5 volt. And in the high side, your noise margin is 2.5 volt. So this is called noise margin. That means that is the highest amount of noise your circuit can sustain, your circuit can get, yet it will give you the correct result. Noise means what noise does? Noise actually temper with your input and output. Noise changes your output, right? But that is what you do not want. That is what you want to avoid. Remember, if you design your circuit correctly, it will have the maximum amount of noise sustainability, noise margin. In this case, our noise margin is 2.5 volt. Why? Let me give you an example. If your graph goes like this, let's say it is 1.5. So your noise margin is now 1.5. Although the high side has a big margin of 3.5, but that doesn't matter because the minimum noise margin is 1.5, right? That maximum we do not count, minimum we count. That is the minimum strength of your circuit. So when your graph goes through the middle, that time your noise margin is maximum 2.5, 2.5. That means VDD by 2, half. And this phenomenon is called skewness. Remember this word. SKEW. Skewness. This is called skewness. Skewness is the beta ratio. Beta P divided by beta N. Remember, this is called beta ratio. If the beta ratio is 1, it will go through the middle. It will go through the middle, right? So for this is the 1. When your beta ratio is more than 1, your graph will go through here. This will be called high skewed. Do not worry, we will learn about this later. we have a big topic on this. This is called high skewness. If the ratio is okay, when the beta ratio will be 1, when beta p is bigger. When beta p is bigger, that means when you make these, let's say 16, that time it will go that way. Remember when we start with 13, that time it was a bit here, right? When you make it 12, it got back, right? So when your beta ratio, that means beta p is more than 1. Now when your beta p is more than beta n, when this is bigger, you will have more than 1. This is bigger means when the value is bigger. Okay, that time you will have a graph here. When this is bigger, that means when it is less than 1, when the ratio is less than 1, the graph will go through the left side. That time it will be called low skewed. Or low skewness. Okay, when it will be bigger? When W and L, when this one will be bigger. Okay, we will see that. We will see that. Do not worry, we will see that. Now, I told you already that your beta ratio is the main key here. Beta ratio. Okay, what is beta ratio? Beta P divided by beta N. What is beta? What was the formula of beta? Mu COX W by L, right? That was the formula we seen earlier, yesterday. This is also the same, beta P, beta COX W by L. Remember, the COX, they are actually what? They are actually constant. So we can erase those. Okay? Now, which one is unknown? These are not same. These are different. So we can call it beta P, mu P, W P, L P. We can call it mu N, W N, L N. Now here, mu P and mu N, they depends on the characteristics of electron and proton. No, electron, not proton actually. They depends on the characteristics of electron and hole, actually, electron and hole, both of them. So this is the permeability, not permeability, this is permittivity. This is the permittivity of the medium. So it depends on the velocity of the carrier. In case of N type, that means the N mass, it is mu N. It depends on the velocity of electron. In case of P mass, it depends on the velocity of hole. It depends on velocity of electron. It depends on velocity of hole. Velocity of hole, velocity of electron. Which one is bigger? Who can tell? Which one is faster? Electron is faster or hole is faster?
Electrons.
Electrons are faster. How much faster? Any rough guess? Rough guess. Do not have to know. Just rough guess. Electron is faster 2 to 3 times. Okay? 2 to 3 times. Remember in your first class, I have shown you a animation video of electrons, of a diode, right? Remember? What happens? Electron moves smooth, right? Jump and hole moves by jumping. So which one will be faster? Electron will be faster. Let me give you an example. Let's say Shojib and Abdiaziz. Both of them are at the starting point of a field or of a running track. Now, Shojib will run and Abdiaziz will jump. Who can finish the race faster? Anyone? Anyone? Shojib will run and Abdiaziz will jump. Shojib will finish faster, right? How much faster? 2 to 3 times faster. Now, is it 2 times or 3 times? Which one? On what it will depend? It will depend on many things. It will depend on the strength of Abdiaziz. It will depend on the strength of Shojib. It will depend on the condition of the road, right? It will depend the condition of the weather, on everything. It depends. So we do not know how much it is. It can be 2 times, it can be 2.5 times, it can be 3 times as well. Okay? That is why we have done our first lab to find out, is it 2 times or 3 times? Okay? Normally, if we do not know, then we consider it is 2 times. If we do not know. But if you know, then you can use 3 times or 2.5 times, something like that. Okay. I'm going to erase this. Now here, this one is slower, this one is faster, this one is bigger, okay? This value is bigger, this value is what? Smaller, because I told you this depends on the velocity. The electron velocity is 2 times. Let's say I'm going to replace this with 2. And I'm going to replace this with 1. Okay? Understood? Because that was 2 times, that was 1 time, that was 2 times. That's why I replace with 2, I replace with 1. Now, are they equal now? Our target will be making them equal so that the ratio become 1, right? Got my point? Everyone?
Yes, sir.
Okay. Now, how can we make them equal? They already become shifted. This one already become double. This whole term, that is this term, already become bigger, right? Because we have a 2. So how can we make them equal?
WP LP bariye.
Exactly. We can increase the WP by LP. Right? Okay. So normally we do not change the ln. We keep the LP and ln same. That's why they can cancel each other. Okay. What you are left with? You are left with 1 WP and 2 WN. Okay. Normally we keep LP and ln same. Why we keep them same? Because changing 2 things are not good. So that we keep one of them constant and we change the other one. So it will give us more flexibility in calculation. So here, so how can we make them equal? We can make this one double than this. So what will happen? We can make this W, that is twice, and we can make it once, right? 1 time, 1. So what will happen? They will give us the beta ratio 1. Understood? This is why your WP is twice the WN or thrice. I told you 2 to 3 times, right? So your WP will be 2 to 3 times of your WN. Make sense? Because your W was 12 micro, your L was 3 micro, right? For NMOS, your W was 4 micro, your L was 3 micro, right? Make sense? So your L and L, they are actually same, so you do not have to worry about those. We worry about W. Obviously, you can change these and you can change the whole ratio. Obviously you can change the ratio. But normally we do not do that. We keep the L same. So W is 12. And bola?
Sir, ठीक है, sir.
Okay. Your WP is 12 and your WN was 4. Make sense? Why they are 12 and 4? Because I told you your WP is equal to twice the Wn or thrice the Wn or 2.5 into Wn, okay, 2 to 3 times, right? So how much is this? এখানে কত আছে? How many times? Thrice. So 3 times, right? So your WP is 3 times the Wn. That's why your graph goes at the middle and your ratio is 1. Understand the ratio?
Yes, sir.
Okay. Now I want you to calculate for any circuit. This was for NOT gate. How to calculate for other circuit? There is a formula. There is a mathematical calculation. Okay. So let's do that. Let's say we want to do the calculation for AB plus C sizing, transistor sizing. So what is the graph? What is the circuit? A, B, okay, this is your circuit. Now what are the formulas? See this one. You have to calculate for p type first, then n type, or n type first, then for p type. Okay, whatever you wish. I want to calculate for p type first. Okay, p type. So for p type, the formula, okay, at first what we have to do, we have to find out the path. We have to find out the path. What do I mean by path? I mean this. From here, current can come, current can go to the A, current can go to the C, then it can go to the output, right? So your path number 1 is AC. That means through A, through C. Next, the current can come, current can go to the B, then go to the C, then go to the output, right? So your path number 2 is BC, right? Is there any more path here? Is there any more path?
No, sir.
No. So it should be BC, right? Okay, BC. So what you have to do? You have to calculate for both of them. But since both of them are equal path, so here how many MOSFET you have? How many MOSFET? 2. How many MOSFET do you have here? 2. So if you do calculation for this one, the same calculation will be applied for this one as well. So do the calculation for one path only. That's enough. So I am going to do the calculation for AC. For AC, the calculation will be, for AC, the formula calculation will be 1 divided by, oh my god, so big, 1 divided by beta P. Since it is PMOS, right? We are doing for PMOS. P, it should be reference. Remember, reference. What is reference? Reference is your NOT gate. Reference is your NOT gate. Beta P reference equal to 1 divided by beta P at first for A plus beta P C. Okay, 1 divided by beta P reference, that is the NOT gate. 1 divided by beta P A for this one, plus 1 divided by beta PC for this one. Okay, if you have 3, 4, 5, 6 MOSFET, you will just add those. Understood? Okay, what is the formula of beta? Mu COX W by L, right? Agree?
Yes, sir.
Now, mu is constant, COX is constant for the material inside, right? That is already done. We cannot change those, can we? We cannot change those, but we can change W and L. So, beta is equal to WL. We will write W and L. So, 1 divided by W by L. Now, remember, this is for reference circuit. Reference means our NOT gate. This is for NOT gate, equal to 1 divided by W by L. This is A. 1 divided by WL. This is for C. Okay, we will keep L is equal to 1. We will keep L is equal to 1 because I told you before our L will be fixed, right?
Yes, sir.
Okay. Now the ratio of WP by WN, the ratio must be what? 2:1 or 3:1, right? Remember? So if it was 12 micro and 4 micro, so what is your ratio now? 3:1, right?
Yes, sir.
It can be 2:1 as well. So at first let's do with 2:1. So it is 2, it is 1. So your WP is 2. So your WN is 1. What is your L? L is always 1. We will keep L always 1. What do I mean by 1? 1 doesn't equal to this one. 1 means they are always same. That's why. Okay. Now, I'm going to put this value here. How? 1 divided by, what is this? This is for PMOS or NMOS? This is for P type or N type?
P type, sir.
This is for P type. Okay, you can write P. Okay. Now, WP by the LP ratio for reference. What is the reference? 2, right? So I'm going to write 2 in case of WP. What about LP?
It's fixed 1.
1, fixed 1. Equal to 1. This one I do not know. This one I do not know. But I know these. This is 1. Right? This is for A, this is for C. Now here, which one is unknown? WPs are unknown, right? This one will go up. So your final value is 1 divided by 2 equal to 1 divided by WP plus 1 divided by WP. Since they are same, they will be same, A and C, their sizing will be same. So can I write 2 by WP?
Yes, sir.
Okay. So here, okay, I'm going to erase some of it. Now, from there, these two will be multiplied. This one and this WP will be multiplied. So your WP is how much? 4. This is for A and for C, both, right? Your WP is what? How much? 4.
4.
Understood?
Ji, sir.
So for this is for A, this is for C. Now if you do for this path, what will happen? You will get the exact same result for B and for C as well. Understand?
Yes, sir.
Exact same result. So what do I mean by this? See, for A, your WP is 4. Your L is how much? 1. For B, your WP is 4. Your L is how much?
1.
1. For C, your WP is 4. Your L is 1. Now, there is a significance of this this thing. What is that? Remember your coding. Remember your coding. So if your W for NMOS was 4 micro, right? It was 4 micro, right? Now your WP will be what? How much? It was WN for 1. It was 4. Understand? See, how much it would be? It would be 8, right? But because why? See, for WN was 1. 1 become 4 micro. How much your 2 become?
8.
8 micro. How much your 4 become? See, 1 become 4 micro, 2 become 8 micro. How much your 4 become?
16.
16. So this will be your 16 microampere. Sorry, micrometer. So this will be 16 micrometer. This will be 16 micrometer. So what actually we find here? What is this actually? This is a number of multiplication. How much we will multiply? Understand? This is a multiplication factor. We have actually find out the multiplication factor of our sizing, not the actual sizing. It's the multiplication factor. So up to this is okay. So multiplication factor only hobe, because we know if it is 4, it will be multiplied with 4. If it is 2, it will be multiplied with 2. That's it. And what about this L? L will be fixed. Understand? Okay. So if you do not understand, I believe you can see the video and you can actually you can clear yourself up. Now we will do for the NMOS, N type. Not clear, not clear. So for easy to remember, always write the number, what you got. Only the W is enough. L is not required. W is enough. Okay, write those W so that you do not forget. Now for the NMOS, at first find the path. How many paths do you have? One is AB, right?
Yes.
So AB.
AB is
Another one is
C.
only C. So since they are not equal path, are they equal?
No.
Since they are not equal path, we have to do all of those. So at first, let's find out for AB. Remember this: always find or always start calculation for bigger path. Always start calculation for bigger path. Okay.
Okay.
Okay. Now for AB. For AB, the calculation will be again 1 divided by beta n reference equal to 1 divided by beta p what? A, no, not p, sorry, actually, I made a mistake. It should be beta n plus 1 divided by beta n b, right? Understood? Now, what is the reference formula? Again, W by L, right? Since it is NMOS, we can write N reference equal to 1 divided by W by L, again N, this is for A, 1 divided by Wn, Ln, this is for B. Now, I told you our L should be 1, right?
Yes, sir.
So I'm going to write 1, 1, 1. What is your Wn? What is the reference? What is the not get reference? 1, right? So I'm going to write 1 as well. And they will be equal because they are in the same path. So they will be equal. So can I write in place of 2? Can I write 2 here and delete another one? And I can write AB. Or I can erase those because I know it is for AB. Now I'm erasing the bracket. What will happen? This one will go up, this one will go up. So what you are left with? 1 divided by 1, 2 divided by Wn. So multiply. So your Wn equal to how much?
2.
2. So your A is 2. Your B is also 2, right?
Yes, sir.
Because this formula is for A and B both. Now for C. Since C is the smallest one, we will find out. Since they are not equal, so we have to do this twice. For 2, that means for path C. What is the formula? 1 divided by beta n reference, 1 divided by beta n what? What we will have here? C. And do we need this? আমাদের এটা লাগবে? Because we have only one MOSFET. That's why we need only one. We do not need this.
Yes, sir.
So let's write 1 divided by W by L.
N,
Since they are NMOS, so N
W,
N,
L,
reference
reference,
equal to 1 divided by W N by Ln for C. Okay? Again, we know our Ln and Ln are 1.
1.
1 and 1. I can delete the bracket. Since it is ratio, it is a reference, and reference is also 1, right? Okay? This one will go up. That one will go up. So multiplication. So your Wn is equal to what?
1.
1. So go there and write it there. Understood? This is your sizing. Now if you want to do the programming, what you have to do? Remember, okay, let me cancel this one and let me take a screenshot. Now you want to do the programming, right? Okay, you want to make a program of same circuit. How to do that? See, at first you have to do the noding, right? Remember the noding? You have to do the noding. So which one is your node 0? This is your node 0, right?
Yes.
This is your node 0. I'm going to write. This is your node 0. Then okay. Then
Node 1.
after that you have to write the node 1. So the input are node 1.
Yes.
This is your node 1, this is your node 1. Okay? This is your node 2, this is your node 2. This is your node 3, this is your node 3, right? All three input, node 1, node 1, node 2, node 2, node 3, node 3. Now come to the node 4. Which one is your node 4? This one is your node 4, right? So I'm going to write node 4. This one will be your node 5, right? Next, let's use a color. This one will be your node 6 with your capacitor, right? This one will be your node 4, 5, 6, 7. This will be a 7. Okay, now write them. Let's write them. This is your 4. This is your 5. This is your 6. This is your 7. Okay. So how to write those? How to write the programming? See this one. How many MOSFET do you have? 1, 2, 3, 4, 5, 6, right? I have 6 of them. So 3 PMOS, copy, 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 right? 3 NMOS, copy, copy, copy. Understood? These 3 are the PMOS, these 3 are the NMOS. Understand, everyone? Okay. At first, I'm going to write MPA, MPB, MPC. Enough. Next one, I want to write MNA, MNB, MNC. Understand? So which one is MPA? This PMOS A. Which one is MPB? This one. MPC. This one. MNA. This one. Understand? বুঝতে পারছি? You got it?
Yes, sir.
Okay. Now, MNB is this one. This one. MNC is this one. Understand? Now, let's do the sizing. Let's do the sizing first, then do the noding. What is that? 4,
Yes, sir.
4, 4, 2, 2, 1. Always start with 1. Which one is 1? MNC, right? MNC. So MNC is 4 and 3. That is our standard. Okay, let's keep it like that. MNB, that is 2, that means twice. So it will be 8. L is same. MNA, that means the N type. A, that is also 2. So that will be 8 as well. Understand this? This is 1, 2, 2. So 1, 2, 2. That means 4, 8, 8. Got my point?
Yes, sir.
Everyone? See, C is 1, Here C is 4, B is 2. So here B should be double. A is 2. That means so A should be double. So 4, 8, 8. Understand? Now come here. Here C is 1. Here C is 4. Here C is 4. Here C should be what? See, 1 become 4 micro, 4 become how much? 16, 16. Here,
Eight.
since it is 4, that means 16. It should be 4, it is also 16. This is also 16, understand?
Yes, sir.
Got my point?
Yes, sir.
Exactly. So now you can do the loading. So this one, MPA, drain, gate, source, body, drain. So 5, 1, 4, 4. 5, 1, 4, 4. Next one, drain, gate, source, body. 5, 2, 4, 4. Okay. Next one. Here, C, drain, gate, source, body. Drain is 6, 1.
1,
No, not 1. It's actually 3.
3.
6, 3, 5, 5. হ্যাঁ কি বলো? Okay, this part is done. PENH, PENH, PENH. That's done. Now next, come to the next one. Drain, gate, source, body. Drain is upper. That means 6, 6, 1, 7, 7. B, drain, gate, source, body. Drain is 7, gate is 2, source 0, body 0. So 7, 2, 0, 0. For C, drain, gate, source, body. That means 6, 3, 0, 0. That's it. Now your VDD is 4, right? That means pin number 4. So node number 4. So 4, 0, 5. Now you have how many inputs? 3 input. One is VA, VB, then VC. So first one is connected at pin number 1. Second one is connected at node number 2. Third one is connected to node number 3. So everyone is pulse 0, 5, 0.3, 0.3, 0.3, 0, 5, 0.3, 0.3, 0.3, 0, 5, 0.3, 0.3, 0.3. But the only change will be this one. This one will be 40, 80, 80, 160. Why is that? I will explain. Wait a second. Okay, for this, if all of them are equal, 20, 40, 20, 40, 20, 40, this will be the case. This will be the case. Understand? So what we are seeing? We are seeing 0, 0, 0, 1, 1, 1. Again 0, 0, 0, 1, 1, 1. So we are actually seeing only two combinations, 0, 0, 0, 1, 1, 1. But what about 0, 1, 0, 1, 0, 1, 1, 1, 0? What about those? We cannot see those. Understand? Got my point? So that's why we will make them double. If we make them double, look at this. Double. This one will be again double. Okay. Now what we are seeing, 0 0 0, 1 0 0, 0 1 0, 1 1 0, 0 0 1, 1 0 1, 0 1 1, 1 1 1. We are seeing all combinations, right? 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. We can see all combination if we do this. If we double our timing, we can see all of those. Understand my point? Now, our circuit is not completed yet. So since this was 4, 5, 6, right? Our, what is that? Our capacitor will be connected at what? At number 6, right? Remember? So we will write like that as well. Our capacitor will be connected 6 and it will be 50 femtofarad. We do not need DC analysis yet. Why? Because DC analysis, the purpose of DC analysis is done. What was the purpose of DC analysis? To find out if we use this material, it would be 3:1. Remember, this is not 3:1. This calculation, this math we have done using what? 2:1, right?
Yes.
So this will not work. This math will not work, but still you can understand, right? Because in our this lab, first lab, we have found it was 12:4. That means 3:1. So we should have done the math using 3:1. So I will be giving you the math for 3:1. So you will be doing that and change those. Understand? Got my point? So DC analysis we do not need anymore, gone. And transient analysis will be up to how much? How much? What is the highest time we have?
160.
160. So it will be at least 160. So that's it, done. So now if we save it, how? Let's say ABC dot CIR, obviously, and it should be all file. Save. This is the ABC. If I double click, you will see this is that. If I run, no error. VA, VB, BC, and the CL. Okay. So which one is VA? VA is the green one. You can see this is the VA. Now I'm going to. Which one is VB? VB is the red one. This is the VB. See, it is the double. Which one is the C? C is the C is the purple one. This one. Okay? 4 times. Now I want to see the output. Output is the yellow one, this one. Understand? So here, let me show you, is it all right or not? So for A, 0, 1, 0, 1, 0, 1, 0, 1. For B, with a different color, 0, 0, 1, 1, 0, no, maybe. I made a mistake. At first, they start with 1, not 0. Okay. At first, 1, 0, 1, 0, 1, 0, 1, 0. Next, 1, 1, 0, 0, 1, 1, 0, 0. Next one, 1, no, different color. 1, 1, 1, 1, 0, 0, 0, 0. Okay, so this one is A. This one is A, this one is B, this one is C. So what is your output? Your output is this one. I'm going to draw the output now. This is 0. What is your formula? Your formula is AB plus C, right? Bar. Okay? Understand? Now see whether the output is all right or not. So when it is AB plus C, so 1 plus 1 plus 1. No, not 1 into 1 plus 1. So 1 into 1 plus 1 whole bar. So obviously the result is 1 bar. So result is 0, right? So this is correct. Let's say this one. So 0 into 0 plus 1. So result is 1 bar, that is 0. So this is also correct. For this, 0 into 1 plus 0. So result is 0 whole bar, that means 1. So this is correct. Let's say this one. 0 into 0 plus 0, because A, B plus C whole bar, 0 bar is equal to 1. So this is also correct. So this is how you can check the result. Understand? Understand everyone? Hello?
Yes, sir.
So I believe that was the theory and lab both. Why I have done theory and lab both, because this is all related. If you do not understand the theory, you cannot do the lab. If you do not understand the lab, you cannot understand the theory as well. Okay, so VLSI course is not theory, not lab, it is combined. Always remember. Okay, hello.
Okay, sir.
Okay, so I'm going to stop here today.
Yes, sir.